Hi guys, thought I'd show you where I'm at on the other project I've been working on, which is the wire recorder. Pretty much all the parts have been redone and replaced that needed to be replaced, other than I've got there's a can capacitor that sits here that I need to restuff yet. I had to wait, I had to order a cap for that, and it came in. I was out of them. This once I get that in, then I can go ahead and fasten this down in here and get the controls located in and finish soldering up the other caps. These guys will go to the control here. It's the on and off volume control, and get that pretty well locked in. That being said, the other part is the motor and mechanisms. So I got the top temporarily on so that I could have made my adjustments for this one. Here's the mechanism. The adjustment is made right here. You have a screw and you have a jam nut. The jam nut locks down and holds it solid once it's adjusted. And then there's adjustment here for in play. I still got to get that adjusted, but I got the height adjusted for this take-up reel. And then once it's all, I get the other unit together and I get this on here. Once the top's on here, then I put a reel wire on and run it. You set your reel on here and you run it through here, through your head, recording head, and hook it on here and run it to get this height adjustment done. They should track pretty nicely as it runs. So this here moves up and down as it runs. Of course, setting on the side like that, I don't want to. Gravity takes it down, but hope you can see that. Oh, you can't see anything. But this will move up and down as it runs. It's hooked into a gear here. It hooks here and operates this up and down. Make the final adjustments on this and then it'll be ready to go. And then that sets back down on top. There'll be 4 screws that holds it down. So anyway, I wanted to show you where I was at on this. I'm gaining on it. Now I want to talk about a few other things. I was watching a video the other day. It was an older video, and gave me some brought something to attention I've never actually ever talked about. And that's pop rivets. Now pop rivets come in variety sizes and lengths and everything. I have an Arrow brand pop rivet gun. It has 4 different sizes ranging from 3/32 in diameter to 3/16. Pop rivets also come in different lengths. This is an 1/8 inch by 1/4 inch length. You can get them quite long, so if you got like a lot of material, real thick material to put together, you can do it. But something I wanted to talk about was, what if you have something like this? This happens to be a focal chassis, but that you've got to replace these. These are what retains the tube shield. Tube shield slides over this, and what if they were chewed up, damaged? Sometimes they are. In fact, this one's got a ding in it, but that's minor. I can straighten that. But I've had them where they were chewed up, and the main reason they are is because they use other style tubes, mainly metal tubes, which have a larger base. But trying to get a regular pop rivet gun down in there, it wants to turn at an angle. Now, that presents problems, but what you can do is something of this nature. Now, the length of this can vary depending on the prop rivet gun you're using. Most prop rivets are pretty standard in this length here of the shaft, but you slide this over, and what this works out to be, I think, is about 5/8 of an inch or about 9.5 millimeters in length, which seems to be about pretty close to max that this prop rivet will grab it, which it's grabbing now. But by using it, it allows the pop rivet gun to set straight on. So you can do something of that nature. This is just a little tubing. You can get these, buy these at hardware stores or something like that. Different types of tubing. You get brass. This is steel, I think, or maybe aluminum. Now, to let you know that this is actually working, I've got a chassis here, and I'll stick that in there. Well, now now it's not going to work on me. It was working. Now I don't want to catch. It may be that this thing is not quite, I don't know, I didn't have any problems when I was doing this. Before, of course, video always gives you trouble. I can use a little shorter one if necessary. Well, I popped one rivet in here and it worked. Give me a second and I'll see if I can find something else to work with that. That'll still work. That one seems to be catching. It's a little bit shorter, so it may just be a little, yeah, it'll still get in there. It's kind of pushing it to get it in there, but it will work. This is a little bit shorter. The size that you use, you want it long enough that you can get in here to the side of that shield. Just long enough and that it'll catch. And that one worked. Now that one there happens to be, and different guns may work differently, so you'll have to practice, you know, experiment. That one's it's just under 5/8 of an inch by probably a 64th of an inch or a little less. But it riveted it. Right there's the rivet. Now it does kind of gouge in there because that piece of metal I just grabbed, and it's a little thinner wall. You can get something thicker that'll actually fit the rivet better and not damage it. Now the other little tip I want to give you is, the nice thing about pop rivets is right now you got a pop rivet in. Anybody's pop rivet know that some of the mandrel is still left in there. You can see it right here. You could knock that out by taking a little punch, smack it, and now it's out. That way you can run a wire through. Now 1/8 inch is a pretty small hole, but like on these chassis here, may through their rivets they may have a grid lead that comes up through. These are much bigger rivets. They're probably pretty close to something of this size. This is 5/32. So these rivets are probably about that size. Once you drive this out, it leaves a, well, you can see the size of that size of hole in there, which will probably, even this heavy wire thickness would fit through that. So you could stick even the thickest wire through, which is, this is just the standard cloth covered, that underneath it's got the vinyl insulation. But if you get some pushback, it would more than definitely go through. But this would go through. In fact, I know it does because I've used it on 5/32 holes. But just a little tip that you can bushing these up and get your rivet gun up so it's not slanted, and allow you to get the rivet in straight. The guns now you can buy pop rivet guns that are just single sized, and a lot of times this shaft is a lot smaller. They only do one size rivet though. You can buy a variety of them for different sizes, but you're buying an entire rivet gun for each different size. Now, two of the most popular sizes I've ever ran into on radios is 1/8 and 5/32 inch, generally 1/4 inch long is usually about best, works about best. But once in a while, a 3/16 rivet, which is smaller than 1/8, comes in handy, especially if you have like a metal placard. I don't have anything here that'll show that, but a metal placard, a lot of times some older radios had a metal plaque riveted on the radio, told the model number and maybe have the serial number on there. And those usually had real small rivets on them. And although I don't ever recall ever running into a real large rivet necessary, such as the 3/16. So just some information to understand and know. The other thing too is pop rivets, you can buy, wherever you buy pop rivets, you can buy washers. These are for 1/8 inch pop rivets, but you can get them for various different sizes. These do come in handy sometimes, especially sometimes with these type of tube sockets where they're two-piece tube socket, phenolic two-piece. Sometimes when the way a popper rivet works is it expands, and sometimes that can break these. So if you put a washer underneath there, you know, when you draw the popper rivet up, it's gonna pull against that washer, which will pull flat against the tube socket and not give you too much trouble. You know, later tube sockets, octal tube sockets, a lot of them generally had a metal piece that actually is what's riveted down, so you don't have to worry about that so much. So anyway, that's just a little bit of stuff. Trying to think if there was anything. Oh yeah, some other stuff to talk about and tips would be, this is more for the newbies, and it's about soldering. For one thing, first of all, always keep your tip clean, and generally a lot of these you can get stands, or if you get a variable temperature soldering iron, they'll come with now the Hakko that I've got comes with both a mesh in here that you can it's dry, you can clean. You just stick the tip in and rotate a little bit and pull it out, and it'll clean the tip. Also a wet sponge it has on there. A lot of them uses the sponge. You can actually buy just this metal as a separate item. It comes in a little holder. But that's number one tip, is keep it clean. When you go to solder or desolder, either case, but when you go to melt solder, whether you're soldering something, you want to heat it up and solder it, or you're wanting to heat it up and to desolder, remove stuff, the first thing to do is wipe your tip, clean it, and then touch a little solder on here. It's called wetting, and wet the tip. What that does is it gives fresh melted solder on there, which will give the greatest heat transfer that you can get. If you do that, you will be able to transfer your heat a lot better and get a lot better job done in soldering, and have less likelihoods of what they call cold solder joints, or if you're melting solder away. Now, as far as unsoldering stuff, the first thing I use is just a standard pump, vacuum pump, desoldering pump. These come in a variety of different styles. They don't cost a lot of money and stuff, so they come in real handy. That gets the bulk of solder off. And then I use solder wick. It doesn't matter what brand you use. The biggest thing is when you're done, keep it inside the case or whatever it comes in. Keep it in there, because it does have resin on it, solder flux that's in it that will dry out if you leave it open. But wetting the gun will also make this stuff work a lot faster and a lot better than if you just go in dry, or just if you just cleaned it and just go in that way. If you give it a little bit of solder, it seems kind of like, gee, I shouldn't be doing it. I'm adding solder where I'm wanting to take away, but no, it increases the heat transfer and gets things going. Now, another thing about this stuff is if it's getting where it's not wanting to work too good, for whatever reasons, I always keep myself some regular paste flux. You can also get flux pens, you can get whatever, and I'll run some of this in here, a little brush or something, just get a little extra flux on it to get it to go working for me if it's giving me a little troubles. Now, I want to talk a little bit to the new guys about tools. You know, I've done videos like this before, but I wanted to kind of talk about what you might need. Just starting out, you know, you're going to get your first radio, which you're probably going to be looking for something that is just a fairly simple radio that you'll feel comfortable working on. Well, what do you need for tools just to start out with? Now, the very first thing I want to talk about is this, and I gotta rotate it. This is an isolation transformer, and let's see if I can zoom in, rotate just a little bit. Alright, now this is a VIS ISOTAP, which is the same thing as I think RCA. This is imperative. This is probably the most important tool that's going to be on your bench, other than what's between your ears. Your ultimate tool and the most important tool at your bench is what's between your ears, your brain. This is second. Beyond anything else, this is second. A lot of radios have no transformers in them, especially by the time you get in the 50s. But there are some earlier than that don't have a transformer, which means there's a good chance that one side of the line cord goes to the chassis. And they're non-polarized plugs, which means you've got a 50-50 chance that you got that plug in the right way, that the hot lead, your 120 volts from your breaker box, is on that chassis. This is a transformer that isolates that, so it doesn't matter. Electrically, you become isolated, so you're not, will never ever complete a circuit as far as that breaker box is concerned. Now, one thing about these that you got to remember, only this side is isolated. This side is direct. So this side is directly connected back from its cord right to your breaker box. This side's your isolated. Now this one's nice. It comes in various different voltages, where it almost works kind of like a variac. You've got low, medium, and high here, and then this matches out to whatever voltage you may be having at your line. So you set it to wherever. But that's an absolutely important tool for your safety. Now beyond that, just assortment, just starting out, some screwdrivers, and I really recommend make sure you get decent. They don't have to be the best. I mean, you don't have to chase down a Snap-on truck, which is a tool company truck, and they're the most expensive tools out there. No, but get some decent ones. Don't go down to your dollar store and buy dollar tool. You'll thank me later, because your real cheapy ones, the tips will wear out real quickly, or may not even be made correctly, and when you go to try to get that stubborn screw out, it'll just, what they call cam, it'll slip out, and it just messes up the screw. It can even get it where you can't get it out with even a good screwdriver. So, you know, a reasonable, decent set of screwdrivers is nice. What else? Well, flush cutters. They're the best, because especially if you do anything on into the 50s and 60s, you may have circuit boards in a radio, and these will get you right down up to the edge when you go nipping the extra lead off and stuff. So, and you can use whatever variety of brands you want. These are little cheapies that like $1.99. These are the Exolite brand. They're around $6. Whichever you want, it doesn't matter. The biggest thing is to remember that even your cheap ones will last you quite a while as long as you're just using them on components and wire. That's what they're designed for. If you start trying to cut something a lot harder than that, it's going to tear them up. I like these because of the thick rubber. It's a lot easier to grab, pick up, where these are fairly thin, but it doesn't matter what brand you buy. Needle nose pliers. Twisting leads, making loops and leads, whatever. Get some short ones for your standard work and some long ones so that you can get down into deep in the radio. Soldering iron. I recommend really to get a variable temperature soldering iron that's around 50 to 60 watts. 3 brands I can think of that they're around $100 in that $100 range, which is really will last you a long time and work really good. Tips are easy to get. Replacement tips, the heating element you can buy, things of that nature, is the Hakko, Weller, and Radio Shack puts out one that's a real decent one. But variable temperature, the reason why I say that is because you want something around 50-60 watts for point-to-point wiring. There's going to be some places where you really need some decent heat and decent power. But at the same time, you may get a radio that has a early circuit board in it. That one you don't want max temperature on. You want to reduce the temperature, or you take a real good chance of lifting the leads. If you got a variable temperature soldering iron, it allows you one soldering iron that does all that you need. Some other tools, just starting out, it's just a digital multimeter. Now I like, and I rarely recommend, a auto ranging. It protects you, protects the meter, and protects everything else, and it'll help you from getting false readings. You know, if you got a ranging one that's ranged and you're fairly new at this and new at electronics, you may set it where you think you should set it, and say you're checking, maybe you're checking a coil or a transformer for resistance, and you set it too low, it'll show infinite resistance, and you'll think, well, it's open. Set it too high and you might think, oh, it's shorted. So auto ranging is probably the best, plus also a cheap, especially a cheap meter that isn't auto ranging, that is just, you know, a $9-10 meter. If you set it too low in voltage, it may damage the meter or burn it out on you. The more better quality ones have fuse protection in them, and these are not supremely expensive. A very valuable tool, a digital camera. So take lots of pictures, every angle, every which way. And if you're tearing into the radio, if you have to dismantle it some, take pictures as you take out components or unhook components. I've talked about this before, but this is an extremely valuable tool. And a digital one, especially a digital camera, which is pretty much what you can get today. Once you take a whole bunch of pictures, you can put it on your computer, download them to your computer. They're there. It'll show up on your screen. You can look at them and get good resolution, and you can see what you're looking for and know where everything goes. Notepad, pencil. You can draw out things and make notes. You know, like if you're disconnecting, say you take out a can capacitor, you want to restuff it. It may have several wires to it. So you can tag those wires with some tape and markings, whatever markings you want to use, just long enough you know what they are. But you can also write some notes about it, telling you well, you know, wire A goes here and wire B goes there, or whatever. You can even draw out little diagrams. Now, that gets you started. Pretty much, you know, of course, one other thing is wire strippers. You know, you're going to have to probably strip some wire, solder, and things of that nature. If you stay strictly for the time being with just AM broadcast band radio, you don't need any more than this. You can do alignment by ear. You can adjust the IF cans by just tuning in a radio station and tweak them a little bit by ear. You know, what you're doing is you're just going to tweak them till it sounds the loudest. And with a little practice, you can get as good enough that if you do it by meter or some other means, you'll be right on the money. The oscillator adjustment, generally you will never have to do this, adjust it. But if you do, pick a station that you know the frequency in the upper band, upper end of the band, say around 1600, 1500, somewhere in there, that you know the frequency of, you know the radio station, you know its frequency, that we can tweak it so it comes in the loudest and when you got the dial set to that point. Otherwise, don't really worry about it unless you know it's way off. But once you move beyond that, you start getting into, say, shortwave, because most people don't. Yeah, I mean, you can look up information on this, but most people don't know the different stations and different frequencies of the shortwave, so you can't really do an oscillator adjustment. IF, it's just still the same IFs, but a signal generator comes in handy, and a VTVM, because a VTVM has a needle on it. It's a lot easier to watch it move up and down scale. Signal generator that's modulated, you can set it to the frequency you're supposed to be adjusting the radio to, your oscillator to, and you can then align where you hear that tone and it's the loudest, or it's the highest on the meter, the scale. You know, the needle moves to, peaks out. FM, you absolutely got to have a signal generator and a VTVM, or even a scope and a sweep generator, especially doing the discriminator adjustment on it. The IFs and stuff, you can, an oscillator you can get by with the VTVM and a generator, signal generator. As far as the scope goes, like I said, on FM discriminator, they actually are easier to do that way than with the VTVM. It produces a S curve, which I did bring the board out to show, but something towards that effect. Right here is the IF frequency. And these are supposed to be, you want this line as steep as possible, and these two peaks, both the negative and the positive going, to be equal. You can do that with the VTVM, but getting the peaks equal takes some time. With a scope, it's going to show up this on the scope, and it's a lot easier to see it on the scope. If you move into TVs and start working on them, then a scope's absolutely necessary. You really will need it for troubleshooting if you have any problems, and also doing alignment. A lot of instructions will only do by visual or with a scope. Some will do VTVM, but then the final check is with a sweep generator and a scope. So I just want to clarify some of that stuff. I mean, as you move up and get along with this, some other tools you can pick up is nice set of, you know, nut drivers, some wrenches, especially, you know, smaller wrenches from like 1/4 inch or so up through 5/8. They really come in handy, especially if you're taking controls out. The nuts on these can be pretty thin, and a wrench is a lot better than a pair of pliers, although pliers come in handy. A little socket set does come in handy, and various other sets of pliers and tools, what they call duckbill pliers. They're like a kind of similar to a needle nose pair of pliers, except they're wider and they're flat. Mine are not in here right now. Utility knife comes in handy. One of these come in handy, and you know, hammer and some punches, you know, the various things. Of course, other things that do come in handy is some inventory parts stuff. Tube tester, starting out, emission testers just fine, and it'll work for you for a long time. When you go, you know, if you run across one that does do mutual conductance or dynamic, you can buy one if it's a good price on it and stuff. That's fine if you want to get one. Let's see. Capacitor bridge comes in handy. I've showed some various things with it. Signal tracer comes in handy, as well as like an audio generator to check speakers and transformers, audio transformers and stuff. So, I mean, you know, as you move along and get a little deeper in this hobby, you don't have to buy all this at once. The basics that I talked about is your initial basics. Again, the isolation transformer, extremely important. But as you move along, you can start buying up other tools as you need them. A lot of tools are not absolutely necessary, but they just make it easier to do a job. So that's about all I've got on this as far as tips and where I'm at on that wire recorder and stuff. This has gotten extremely long, so it's going to probably take quite a while. So anyway, I'm going to stop here and see you guys on the next video. And I want to thank you for watching, and thank all my new subscribers. If you haven't subscribed, go ahead and subscribe. I talk about a little bit of everything on radios and TVs, and thanks for your comments and stuff. I'll see you on the next video.